In the following session, I will teach you how bump mapping works inside a renderer and what is actually being done in order for you to better understand what are the factor, bump step, and all these parameters that makes the actual bump mapping work. So just to go back a little bit, and what is bump mapping? Well, this is one of the very first technique that was used in computer graphics to simulate a rough surface without actually displacing the surface. So as you can see here, we have some sort of textures and it looks a little bit rough, but actually the surface is totally flat, totally smooth. But because of the nature of bump mapping, it will perturb the surface and will make it slightly rough on a per pixel basis, which gives you the impression that the actual surface has a certain level of roughness. What is being done internally is that the bump mapping is actually taking the surface normal at the intersection point right here as the camera rays hit the surface to be able to compute a given pixel or subpixel. It will actually hit a given triangle, and that triangle will have UV values at each vertices, which is these corners right here. And that will actually position the triangle onto the image in order to texture it. Then the bump mapping has to determine how the actual surface normal needs to be bent. So it will actually take the surface orientation and slightly bend it towards either U-axis or V-axis in order to give this sense of roughness. So the first thing that the bump mapping will do is evaluate the actual bump map or the actual texture at the intersection point where the actual ray hit. The image itself is considered as a height map. So it's whenever it's white, it's going to be pushing more like out, and when it's black, it's going to push more like stay towards where the actual surface is. So depending if the factor is negative or positive, you may get an outward bump effect or an inward effect. Now the bump mapping will compute these three values. So it has to compute directly take a sample at the intersection point and slightly move the bump, slightly move the actual sample slightly in U. And to be able to slide this extra sample, it needs to determine what we call UV flow line. So the UV flow line in this particular image is basically the actual image is giving this information. So we can say that these flow lines are basically this way and this way. And so it will actually offset the actual sample slightly in U. So the U bump step is basically this value right here. And it will do the same here for the V bump step, which is this value right here. So this will give two extra intersection point, and those one will also evaluate the texture at this location. With this three dots or three values, height values, it will compute a new normal that will actually shade the surface differently. So to be able to see this in action, I've created this very simple scene where we have a grid on which we have applied this sort of let's say interactive normal display proxy. And so as we slide the value, as we slide the U position in U and V, we actually get the normal that is actually the original normal of the surface. In this particular case, the grid is flat, so the white normal is always pointing Y up in the Y-axis, positive Y-axis, while the yellow one is the bump surface normal. Since there's no perturbation of the surface, there's no height map being given to the surface, then obviously the two aligns. So as we start to increase the bump, we see that the actual U offset and V offset here tends to actually bend to be able to get a sense of the surface. So as we increase these U and bump step will actually look up neighbor samples in order to orient the actual new surface. So we can consider this is the original normal, and this is pretty much a new bump map normal. So as you can see, as we slide, we see that the actual bump normal is actually moving depending on the actual location. So, and also the actual bump factor can be either positive or it can be negative. The bump step here, these are the two actually bump step location, which is basically the same thing as these two extra dots. So the bump step is always expressed in UV domain. So that's why it's so small, because if you want to take let's say the pixel, the neighbor pixel to the sample point, let's say 1 pixel away, then this value needs to be pretty small depending on the actual image or texture resolution. So let's say, for example, if you're using a texture that is 10,024, then the actual bump step is going to be 1 on 10,024. And that will look up the next pixel. So whenever you adjust this, you start to get what we call, this effect where the actual bump step will go and look up a little bit further. So if we go and actually put the bump factor and add a little bit roughness to it. So for example, you see that depending how the actual bump step is set, you may start to lose some details. So actually this value here a little bit too far away and actually is missing some details, which is the nearest bump right here. So these value might be a little bit too large, or the bump step might be too large. By adjusting the bump step right here, we get a little bit better bump effect here. So the bump step is designed to actually grasp all the small details, especially if the texture contains really high resolution textures. This value needs to be set properly in order to pick up all the small bumps and small details inside the actual image. So as we adjust the bump step, it will actually change the way the actual bump map looks in the final rendered images. So as you move the actual bump map, the actual lookup position, you'll see that the actual bump normal is adjusting depending where it is doing the lookup, either at the center right here and also at the U step and V step, which is neighbor samples. So if we start to add a little bit more like depth like this, for example, then you can see that the actual normal will actually follow quite well the surface. So if there's a lot of roughness, then you'll see that the actual normal will flicker and move and jitter because there's a lot of roughness, for example. But if I do make the actual bump pretty large, I will tend to lose this detail because the actual bump step is way too large. So that's why the actual bump step needs to be quite small to pick up all the small details. Now I'm starting to pick up quite a good, like I'm capturing a lot of detail onto the surface, and that allows to get a better result at the bump map renders. So this is how bump map is being done internally, and I just hope you will now enjoy how these better understand how these parameters are being used in the context of bump mapping. Thank you.